Objective 8.4, using exponential decay models. In this objective, we want to be able to use an exponential decay model to set up and solve real-life problems. So let's take a look at what the exponential decay model looks like. Again, we're starting from the basic model of y equals a times b to the x. This is always the basic exponential model, regardless of whether we're talking about growth or decay. Okay, but because we're talking about decay, and because decay can also be sometimes given to us as a percentage rate, we still need that other form of the model, which looks like this. So we still have our a, and now the b is being replaced with this parentheses 1 minus r. The a is still our initial amount. Okay, so none of that has changed, just like we've talked about in the other objectives. But now the b is 1 minus r. That is still called a factor, but now it's our decay factor. And because it is decay, we need this base, which is now the 1 minus r, to be something between 0 and 1. Remember, when it was growth, then b had to be greater than 1. So we took 1 and we added r to it to end up with a factor that was greater than 1. Now we're talking about decay. And in decay, we have to have a base that is something less than 1. So now we take 1 and we subtract the r from it so that we end up with a number between 0 and 1 as our decay factor. The actual r itself is now called the decay rate. Just like we had a growth rate before, now we have a decay rate. This is still a number between 0 and 1 as well. So this is still going to be our percentage rate that we're given in the problem, changed into a decimal number that is between 0 and 1. And just like with exponential growth, the t still represents the time period. Alright, so let's put this to work with an example. This is an example of depreciation. It says you buy a new car, not care, sorry about that, a new car for $24,000. The value of the car decreases by 16% each year. Write a function that models the value of the car over time. Okay, so those same three questions we used with exponential growth, we can still use with exponential decay. And the first question was, which model should we use? Well, again, the fact that we are given percentage as the rate in our problem tells us that we need to use the y equals a times 1 minus r to the t power model. Okay, then we need to identify our initial amount. So that's the price for the new car, that's the $24,000. And we need to identify the decay rate, which is that percent, 16%, which we need to rewrite as a decimal 0.16. Alright, so now we have all the pieces, so we put them together in our exponential decay model, and we get y equals 24,000 times 1 minus 0.16 to the t power. And remember, this is our model to represent the car's value over time because we do not have a specific time yet. But now if I ask you a question like this, what is the value of the car 3 years later? Now you can use this specific model, substitute the 3 in for the t to represent the 3 years. Notice we've also simplified the 1 minus 0.16 to make it 0.84. And now we can work this out with a calculator. to see that the car after 3 years is probably going to be worth about $14,225. Okay, so the basic approach to these decay problems is just like what you did with growth problems. The only major difference is that we need to subtract the r from 1 instead of adding it to 1. Okay, so with that in mind, why don't you try one on your own? You have a new car that costs $23,000. The value of the car decreases at 15% each year. Again, this is a two-part question. First, you want to write an exponential decay model for the car's value over time. And then you want to figure out the value of the car after 5 years. Go ahead and pause the video for a moment while you work that out, and then start it again when you're ready to check your answer. All right, so let's see what we get. For your model, you would use the $23,000 for your initial amount. You would change your 15% to a 0.15 for your rate, and leave the t as t for the first part of your question, writing the exponential decay model. So that's what this first equation shows us. And then to figure out the value of the car after 5 years, we'll substitute 5 in for t, and we'll work out the problem to see that the car would be worth about $10,205 after 5 years had gone by. All right, let's take a look at one more problem. In this case, we are told that there are 40,000 homes in your city. Each year, 10% of the homes are expected to disconnect from septic systems and connect to the sewer system. So write a function that models the number of homes still using septic systems. Okay. Now notice here, when you read through this problem, this is a problem about who's on septic. Okay. We're assuming that these 40,000 homes are all started out on the septic system. That number is decreasing by 10% each year because they're disconnecting from septic and they're connecting to the sewer system. So this is a decay problem, and we need to set it up that way. So again, which model would we use? Well, again, we're being told our rate of change as a percent, so we're still going to use the y equals a times 1 minus r to the t model. What's going to be our initial amount? That's going to be the 40,000 homes we're told are in the city. And what's going to be the decay rate? That's the 10% change to the decimal 0.1. So when we put all those pieces in place, our exponential decay model should be y equals 40,000 times 1 minus 0.1 to the t power. Then we can use that model to estimate how many homes will still be using the septic system after 5 years. So we substitute the 5 in for t, and we work it out to find it's about 23,620 homes. Okay, so why don't you give one more try here before we end this video. You're told that you have 50 grams of iodine 131. So this is a radioactive substance, and radioactive substances decay over time. So this particular substance, iodine 131, decays at a rate of 8% each day. So again, the first part is to write the exponential decay model that gives the amount of iodine 131 still present over time. And then the second part is to figure out how much iodine 131 would be present after 1 week. So pause the video for a moment while you work this out, and come back when you're ready to check this one last problem. Okay, So, because of the fact that we're being told our decay rate as a percent, we're still going to be using our A times 1 minus R to the T model. The initial value is the 50 grams right here that we're starting out with, so that's going to go in for this spot. And our 8% we changed to a decimal to put in for R. So this is our first part to our answer, to come up with this model, which represents the amount of iodine 131 that you would still have over time. Then when you're asked for how much will be present after 1 week, you have to realize that our information told us how much it decayed per day. So you would have to translate the 1 week into 7 days, and then work this out to find you would still have about 27.9 grams left after 1 week's time. All right, that should give you some good information about how to work through the problems on your 8.4 practice. If you have any questions on any of these, make sure you're asking about them during class. I'll be happy to help you out. And when you've completed your objective, please make sure you show me so I can get you checked off the list. All right, we'll see you next class.